Okay, let's have a look at the equation of a line. Over here on the right hand side I've got a number of lines here, each of them slightly different, and we're going to work out the equation of those lines just from what we can see there visually. So first of all, let's have a look at the equation of the line, the classic expression of the equation of a line: y equals mx plus c. Now, y equals mx plus c, y and x are variables, m is the gradient of the line. Is the gradient of the line, and it's equal to the, if you just look at the line, it's equal to the increase in the y direction. So looking at that there, that would be 2. So that we'll just show that here. Delta y being the increase over delta x. So that's the delta y there, that amount there, over that there. So you can go to anywhere in the graph if you want to, if you've got your graph nicely plotted accurately. You can go to any position in the graph to work out the gradient delta y over delta x. Now it does have a sign. You can see here that this gradient here, which if you use your left hand, it's sort of the natural flow of your left hand, and that's a positive gradient. And again, this one, just follow it with your left hand. Put your left hand up there and you can see that the gradient, that the line goes from the bottom of your left hand to the top of your left hand. So that's a positive gradient. However, when you look at this one in example 3, to follow the line, you're either going from the top of your left hand to the bottom, or you have to put to follow it, you have to use the backhand, or what we call the backhand. So that's a negative gradient, that one, going negative. Another way of looking at it is that it goes from the second quadrant to the fourth, and whereas these ones go from the first quadrant to the second, the quadrants being, that's quadrant 1, that's quadrant 2, this is quadrant 3, and this is quadrant 4 here. So there's a number of ways of determining whether your gradient is positive or negative. So negative gradient, negative g, and this one here is positive, follows the left hand. So you can pretty easily, by inspection, see whether a gradient's positive or negative. So that's m. Now I'm going back to the yellow pen. C is the constant term, and it actually represents the y-intercept, and it's it's equal to the y-intercept, there. You can very easily see that, because if you look at this equation here and you set x to x, here when x is 0, which is the y-intercept here, when x equals 0, y equals c. So that's the y-intercept. So to find the gradient, to find the equation of a line, and I'll do those in green just to highlight them here. If we look at this one here, we first of all know it's y equals, and then we look at our gradient. Now there's our increase in y, which is 2. Okay, and here's our increase in x. We don't need to worry about whether it's a negative or positive. in this terms, because we've already worked out that it's a positive gradient because of the direction that it's going. So that's mx, and our y-intercept is 2. So the equation of that line equals y equals x plus 2, because there the 2 over 2 is 1. So let's have a look at this one. Again, it's a positive gradient, so we could go y equals, now our y distance here is 2, doesn't 2, and I've shown here our x component here would be 4 x, and our y-intercept would be -2. So that one's y equals half x minus 2. Okay, looking at this one here, we can see that y equals, so we've got 3 over there, 1 here for the x dimension, and we know that this is negative. We determined it's a negative grade, and here's our y-intercept plus, so that would be x in there, plus 3. I'm just going to check that I've put an x in all the others. Yes, I have. So this graph here is y equals -3x plus 3. -3x plus 3. It could also known as, you can, some like to write it 3 minus 3x, y equals, some people don't like the negative sign out there on its own, so that's just another way of saying it. It's no problem. Now sometimes I should point out that sometimes the y-intercept is 0, so obviously not as easy to work out the gradient. That's why I've dotted these little ones in here. So for instance, and for this one here, the gradient, the equation of this graph is y equals, it's positive, so that's all good, 2 over 2 x plus 0. So this is actually a classic line, y equals x, which is 45 degrees to the horizontal axis here. Not better just complete my diagrams just to tidy things up, be consistent. So that's x and y. So there you are. Quite easy to just by inspection of the graphs to recognize the equation and name the equation of the various lines. Just remember the left hand rule, left hand forward, left hand forward, positive gradient, left hand back, negative gradient. Okay, so we'll just put a bit of magenta around that just to draw good attention to it. Okay, so yeah, use your left hand, gradient equation of a line. There you go, and that's all, folks.